Hi, my name is Dr. Susie Lachowski-Glass, and the title of this video is called Is KAATSU a Cuff? So over the next few minutes, I'm going to describe just a brief overview of what KAATSU training is, and then compare what KAATSU training and the device that you use KAATSU training with comparatively to a blood pressure cuff-like device, as well as a tourniquet, and discuss blood flow patterns and what occurs when you apply each different type of material to the limb. So with that being said, let's dive into an overview of what KAATSU training is. So what is KAATSU training? KAATSU training is a form of exercise that involves the use of specialized bands to alter blood flow patterns to the muscles during low-intensity activities such as walking, cycling, or resistance exercise training. Application of the bands goes on the upper portion of the arm or upper portion of the leg and fits tight or snug enough to only get about 1 finger's worth underneath the band. From there, pressure is inflated into the band system in order to manipulate blood flow patterns. When doing this with KAATSU, we are allowing arterial blood flow to come into the limb. However, we are manipulating venous blood flow out of the limb. This controlled blood flow restriction or alteration creates a hypoxic environment where oxygen levels can be reduced in the muscle and metabolites are then built up. As a result, the body experiences an increase in metabolic stress and the muscle fibers are subjected to a greater strain, therefore recruiting larger and more muscle fibers in order to keep exercising. The physiological effects of KAATSU training trigger a range of beneficial adaptations. The restricted blood flow forces the muscle to rely more on anaerobic energy systems, which promotes the activation of fast-twitch muscle fibers. The increase in metabolite concentrations from these pathways causes the release of various growth hormones and can indirectly stimulate muscle growth and repair. KAATSU training can also induce cell swelling and metabolic stress responses, which also can cause hypertrophic effects of the muscle tissue and aid in increasing strength. Other physiological adaptations that can occur is the release of nitric oxide and VEGF, which affect the efficiency of blood flow throughout the body. These effects can cause improved muscle hypertrophy, muscular strength, increased vascularity, and better overall cardiovascular health. Additionally, KAATSU has been shown to improve muscle endurance and rehabilitation outcomes, making it a popular method for athletes and those recovering from injury. This type of training is advantageous to individuals of all ages and capabilities to enhance overall health as well as performance. So now that we have a little introduction to what KAATSU training is, I'm going to discuss what I like to break into the BFR device categories. And I like to break them into 3 major categories of where a band or a system could fall into. So first category would be considered, I like to call it the non-pneumatic systems. It can occlude or there's no specific measure. So for example, we're not adding air into these band type of systems or these, could be a rigid belt or it could be a tourniquet-like device. So we're going to, for the purpose of this demonstration of this video, I'm going to be talking about tourniquets. The second one is called, I like to break them into, is rigid pneumatic system. They are designed to occlude arterial inflow and venous outflow when you pump enough air into the system, but it is measurable. So rigid pneumatic, meaning you're able to add air into the system. And we're going to dive into the blood pressure cuff-like device in just a minute. And remember, the point of a blood pressure cuff is to cut off arterial inflow in order for us to then, when we release the dial, in order to read systolic and diastolic blood pressure. Now, the last category that a device could fall into is called an elastic pneumatic device. This is designed not to occlude. So here, no matter how much air or pressure we put into the band or into the system, we are still going to have arterial inflow into the system, but we're manipulating venous outflow. So here we are adding air in, it is measurable, but they are designed not to occlude. A blood pressure cuff here is designed to occlude. And we're going to talk about what limb occlusion pressure is in just a second. And then the last one here would be a tourniquet-like device or a device that's just like a belt or a rope or something like that, where you have no set measure of air going into the system. Okay, so next we're going to talk a little bit more about the material of blood flow restriction training bands systems itself. And we're going to break it into the blood pressure cuff-like devices as well as then the elastic pneumatic devices or the materials. Now, blood pressure cuff or blood pressure cuff-like devices are rigid and they are designed to occlude arterial inflow. This means there's no give to the material and the pressure added to the cuff or the band directly impacts the limb and blood flow itself. Now, elastic pneumatic devices, now specifically referencing blood flow restriction or modification devices, are not rigid in nature and they're designed not to occlude arterial inflow. However, they are designed to manipulate venous outflow. These type of devices have give to the material, and it tends to flex and extend with the movement of the limb. And this is where the KAATSU band system falls into. And we're going to be comparing is, again, the KAATSU system a blood pressure cuff or like a cuff-like device. Blood pressure cuffs or blood pressure cuff-like devices for blood flow restriction training utilize a term called limb occlusion pressure when training, or arterial occlusion pressure. It's the same thing. Now, limb occlusion pressure is the pressure applied to the band or pumped into the band applied to the limb to cut off blood flow to that limb. So typically it's just above systolic blood pressure, and there's a varying amount of variables that might affect that as well. However, let's just say for reference example is that the limb occlusion pressure for someone's upper extremity is 160 millimeters of mercury. When you want to exercise, you're typically going to take a percentage of that limb occlusion pressure, so you're allowing arterial blood flow in. So here we know that we're cutting off blood supply just like a blood pressure cuff does, and you need to take a percentage of that and exercise there. Now, comparatively, an elastic pneumatic device is you can add as the theory is, and the point is you can add as much pressure you want into the band, but due to the nature of the band and the material of the way it is set up is that you cannot cut off arterial blood flow. However, you can manipulate venous outflow. So that's just a little introduction here. And then now we're going to dive into just showing you the differences of materials from here on out. Okay, so continuing on with is KAATSU a cuff? The next few demonstrations we're going to be using is a tourniquet, which is again the purpose of cutting off blood supply. We're going to be using a demonstration of the blood pressure cuff and its material and how that is manipulating blood flow patterns to the upper extremity. And we're also going to be using the KAATSU band system. We're going to show you the C4 as well as the B2 to compare all three types of main device categories I was discussing on with regards to blood flow patterns, and what is cutting off arterial inflow in addition to venous outflow. And we're going to showcase these concepts by using a pulse oximeter, and then we'll also use the doppler to showcase the KAATSU band system as well. So the next few demonstrations, we're going to be using a tourniquet, we're going to be using a blood pressure cuff, and then we're going to be using the KAATSU band systems to show the physiology and what is occurring from an arterial and venous blood flow standpoint. Okay, so now I'm going to take my pulse oximeter here and apply it to his finger. We're going to look for a nice O2 saturation as well as a pulse, which is going to indicate good arterial inflow coming into his limb. All right, so he's got good arterial inflow as well as a pulse right there. And in just a second, we're going to be putting on a tourniquet, which is going to attempt to cut off blood supply, which will be indicated on the pulse oximeter if the numbers go away. So we'll do that next. Okay, now I have applied the tourniquet to his upper extremity in order for us to cut off arterial inflow to that extremity. You can see that indicated on our pulse oximeter here, that there is no SaO2 reading and no pulse. So we have successfully cut off blood supply to his upper limb there. And the purpose of a tourniquet is just that, to cut off blood supply for surgical or drawing blood purposes. Now, when I undo the tourniquet here, you should see the left arm start to reperfuse as the arterial blood flow is coming back into the limb, indicated on our pulse oximeter here. As you can see, the pulse coming back as well as the SaO2 readings are gradually now starting to increase as we are increasing O2 saturation. So here's just another angle to show you the hand color difference when we cut off blood supply using a tourniquet. So we've reapplied the tourniquet here and cut off blood flow to the extremity. Again, you can see those veins distend, as well as the left hand is now starting to turn that purplish bluish hue, indicating no oxygenated blood perfusing into the lower half of the arm. Okay, so this can be uncomfortable, but the purpose of this is to actually cut off blood supply, and that's just what a tourniquet does. Okay, so now I'm going to describe the actual material of a blood pressure cuff. You will see its components with its hand pump as well as the dial right here. And as I'm holding it up, you will see it is a wide device. So it is wide and rigid and stiff. So that is the point of a blood pressure cuff, is to be stiff and rigid, because when we add air into the cuff, we actually want to cut off arterial inflow. So that way, when we release the dial, we will be able to record systolic as well as diastolic blood pressure as blood is rushing back into the brachial artery. So the point of this rigid cuff is to cut off arterial inflow. Okay, so for this demonstration, we have applied the blood pressure cuff to his upper extremity. I'm going to take the pulse oximeter here before we inflate the blood pressure cuff to get a nice O2 saturation reading as well as a pulse, indicating good blood flow coming into the limb. All right, so there you have it. He has a nice arterial inflow, a nice O2 saturation as well as pulse. And now I'm going to take the blood pressure cuff and slowly inflate the pressure and see what happens to O2 saturation as his pulse as we gradually increase the pressure into the blood pressure cuff here. Okay, so we're slowly increasing the pressure into the cuff. We're going to go up, hopefully over his systolic blood pressure, and hit what's his estimated limb occlusion pressure, or pressure that's going to cut off blood supply to the limb. So if the blood pressure cuff is doing its job, it should cut off blood supply to the limb in order for us to read systolic and diastolic blood pressure. And there you have it. Right here, we're around 160 or so, 150 to 160 millimeters of mercury, and we have cut off the arterial inflow to the limb, and it is indicated by no O2 saturation and no pulse at the moment at his finger. Okay, so now I'm going to take the blood pressure cuff again and release the dial. So we allow arterial blood flow all the way back into the limb. And we should start to see now a pulse come back, as well as O2 saturation will start to increase again. Okay, so the blood pressure cuff did do its job. It's a rigid pneumatic device, and we cut off arterial blood flow and read that number. Okay, so for this video demonstration, you can see I pumped the blood pressure cuff back up so that there is no pulse or SaO2 reading, indicating no blood flow coming into or out of the limb. And for this demonstration, I'm just going to show you the difference in hand color as we see less blood coming in and perfusing into the left extremity here. So when he's holding his hands up, you can see that the right hand has nice blood flow. The veins aren't completely distended, nice and light pink color. You're starting to see the veins become distended on the left side here, as well as the skin is now turning a purplish or bluish hue, which indicates something called cyanosis. This can also be uncomfortable until we reperfuse and let go of the cuff. Now that I've explained a tourniquet and blood pressure cuff's impact on arterial inflow, we are now moving on to the KAATSU band system, where we will also demonstrate its material, the application, and blood flow to a limb. Okay, so now I'm going to describe the KAATSU C4 band's material just a little bit. So now you'll see here as I'm undoing it, it is a much more narrow band comparatively to a very wide, rigid blood pressure cuff. It has a nice thick material which aids in the comfort of applying it onto someone or to yourself. And then as I'm starting to pull on the material a little bit here, you will see that there's a little bit of elasticity and give to it. This is an important component to the KAATSU band system, as it does not allow us to occlude arterial inflow or venous outflow. So now we're going to show you just again the application of the KAATSU band onto the upper extremities. Going to put it on the upper arm here, right below that deltoid insertion, and cinch it tight enough just to get about 1 finger's worth right underneath the band there. And then from there, without it inflated yet, I'm going to take this SaO2 monitor, or the pulse oximeter, place it on his finger to get a good reading of O2 saturation as well as a pulse, indicating again good arterial blood flow and that we're not cutting off blood supply yet. We have not inflated the band yet, so we should have nice arterial blood flow, and there it is. Now I'm going to take the remainder of the KAATSU system and then plug in the band in order to inflate to various pressures and monitor the SaO2 unit. So here we go. We're going to plug in the band. I'm going to go to advanced. We're going to go to constant just to showcase different pressures here for this demonstration. For the first pressure we're going to look at, we're going to go up to 150 standard KAATSU units or millimeters of mercury and hit save. I'm going to hand the unit over to him so we can watch the demonstration. And then as the air is completely pumped up, you will see within the system is maintaining pressure, as well as he is maintaining his pulse and his O2 saturation. So meaning right now at 150 millimeters of mercury or standard KAATSU unit, we are not altering or impeding arterial blood flow. So I'm going to hit stop. And next we're going to go back into advanced and constant, and we're now going to pump up the pressure to 250 standard KAATSU units or millimeters of mercury, which is a higher pressure for the upper extremity. And we're going to monitor also what happens at the O2 monitor. Okay, so we're going to hit save. And now the band is inflating to 250 millimeters of mercury or standard KAATSU units. We're going to hand that off. And we're going to continuously monitor the pulse oximeter, which is going to be indicative of O2 saturation, arterial inflow, and pulse, which we can see we have good O2 saturation, we have a good pulse. So we have input in now a much higher pressure into the band, and we can still see we are maintaining our pulse as well as our O2 saturation. Okay, so with the system still inflated 250 millimeters of mercury, we can still see we have a good O2 saturation as well as a pulse indicating good arterial inflow. I'm going to remove the pulse oximeter here, and we're going to observe any sort of color differences within the two limbs. So when we look at the hands, the two hands have a very similar color. We are not observing a darkish purple or bluish hue to the arm that has the band pumped up. However, we are starting to see a little bit of the veins distend, indicating venous pooling, which makes sense because we are manipulating venous outflow on that limb with this system. So next we're going to set up the C4 in constant mode. So we're going to click advanced, we're going to constant, we're going to click upper extremity, and then we're going to go up to 250 standard KAATSU units, which is representative of 250 millimeters of mercury, which is a high pressure for the upper extremity. So we're adding the pressure into the band system now. And we're just going to showcase a different way where arterial inflow is not compromised with this system by utilizing a doppler. So next I'm going to grab my doppler, and then we're going to go ahead and showcase that the arterial inflow is maintained as well. So I'm just going to demonstrate one last way you can confirm that there's arterial blood flow coming into the limb by the use of a doppler. We have pumped up the C4 band system to 250 standard KAATSU units or millimeters of mercury, which is a higher pressure for an upper extremity band. I'm going to take my Doppler right here and find his brachial artery and find nice, strong brachial inflow, which in just a second you can hear. And there you can see that arterial inflow is maintained while the band is pumped. So now I'm just going to provide a demonstration of the KAATSU B2 band system. And the difference here is that this system or these bands, when applied to someone, is going to be controlled by an app on your phone where you alter the pressures and the session from there. You will see that the material is the same as the C4, and as I pull on the material, you will see it has that elasticity and that give to it, indicating it is a elastic pneumatic device, and then we turn on the system, which will then connect to the app. So now we are going to demonstrate the KAATSU B2 system and its setup. So once it is applied to the limb, we're going to turn it on and then open up our app on our phone right here. We're going to open up the KAATSU app. We are going to go into the advanced mode, and we're going to start Bluetooth pairing between the band and the app itself. So we're going to go to the left. Since the band is on the left extremity here, it should find a device. We will pair it, and then we're going to hit next. And then we're going to go to constant, since we're going to do the same demonstrations as we did before with the other systems. So we're going to press arms, hit next, and then again to the left side, and we're going to pick the 250 standard KAATSU units, which is representative of millimeters of mercury, the pressures that is being inputted into the band. So once we hit OK and we hit start, now the band itself is connecting through the Bluetooth feature on the app, and you can see it is lit up blue here. So the band is now pumped up to that 250 standard KAATSU units, which we can then monitor from here. And then next we will continue on with the remainder of our demonstration with the pulse ox and hand coloration. Okay, so now that we pumped up the B2 band system, I'm going to take my pulse oximeter here and to see if we can read a nice O2 saturation as well as a pulse, which would indicate arterial blood flow coming into the limb. So you can see still here on the app that the band is pumped up to that 250 standard KAATSU units, which is indicative of millimeters of mercury. So as we zoom in here, we should still see a pulse and an SaO2 reading, again, indicating good arterial inflow, which it is showing here. So this is proving that, again, this elastic pneumatic system is allowing arterial blood flow into the limb. So now we are going to look at the B2 system with the hand coloration, just as we did before. So we have our band pumped up, as well as our pulse oximeter reading SaO2 and a pulse indicating arterial inflow still coming into the limb. When we look at the two hands, you can see that the hand color differences are not very different at all, indicating good arterial inflow into the limb. The veins may start to distend on the left side because the more we restrict or alter blood flow patterns, the more we will pool. Okay, so now let's conclude our video titled, Is KAATSU a Cuff, or should we classify KAATSU as a cuff? You see over here we have a blood pressure cuff, which we did plenty of demonstrations on, as well as the KAATSU band system over here. So with the blood pressure cuff, I explained how, again, that it is a rigid pneumatic type of device, and the point of that is to cut off arterial blood flow to the limb in order for us to read systolic and diastolic blood pressure as we allow blood flow back into the limb. So the point of a blood pressure cuff is to cut off blood supply when we go up and over our what's called our limb occlusion pressure, which is the pressure applied to the limb that cuts off blood flow to the limb. And then we provided examples of the KAATSU band system, of the B2 and the C4. We showed you that there's the difference in band material here has a little elasticity to it, and it has a little give to the material, which tends to flex and extend with the limb itself as you're exercising. So here we saw with the blood pressure cuff that when we increase the pressure past its limb occlusion pressure to cut off blood supply, we showed that indicating on our pulse oximeter where the pulse went away as well as the SaO2 reading went away, indicating we had no arterial blood flow into the limb at that time. When we applied the KAATSU band systems and using various pressures, you could see with the pulse oximeter that we still had an SaO2 reading as well as a pulse coming through, indicating still arterial inflow coming into the limb and into the artery, which is serving the muscles and surrounding tissues. However, we are manipulating venous outflow with that system as indicated on some of the distension with the veins, and that is the point of altering blood flow patterns there. So if we were to conclude, is the KAATSU band system a cuff? I would not classify it as a cuff itself, because how I define a cuff would almost be like a blood pressure cuff, which is a rigid pneumatic material, which is designed to, again, then shut off arterial inflow. So I would not classify, due to the material, to the band setup, and the way it is made, I would not classify it as a cuff. So how would I classify the KAATSU band system? If we went back to the beginning of the video when I talked about the 3 different categories for blood flow restriction training devices or modification devices, I would classify KAATSU into the category of an elastic pneumatic band system, but that this system is more of a specialized band that you can alter blood flow patterns with varying pressures. However, I would not classify it as a cuff because of the material differences and its inability to actually shut off arterial inflow. So I hope that this video was informative to those who are wondering the differences sometimes of bands or the systems that you may have questions on. And if you have any more questions, feel free to always reach out. Thank you.